In this video, we'll consider some of the ways that you can compare information. So you just saw the video with composite experts, if you're looking at these in sequence, and you saw that we generated this particular graphic. What we're going to do is double back now and talk about how you can display information to convey these differences that we see. So here we have the without condition, the probability of establishment of Asian carp by 2021. This is a box and whisker plot. So the way this works is from the far right here up to the beginning of this box, this is the highest 25%. This is the fourth quartile of data. From this leftmost whisker up to the beginning of the box is the first quartile. So 25% of all the values are spread over this distance. 25% are spread over this distance. The box itself gives you the middle 50%. The vertical line in the middle of the box is the median value. So this is the first quartile, and then from the beginning of the box to this vertical line is the second quartile. Then to the other end of the box is the third, and then the fourth. So you see there's more spread among the high and the low values than there are among the middle values. The range from the far left to the far right is an indicator of the uncertainty that this expert had about this value. And then of course we can look at the scale itself. This expert is basically saying there's about a 50% to a 90%, 95% chance that Asian carp will become established by 2021. Contrast that with expert 2. This expert's uncertainty is so small that the entire box appears as a vertical line, as a zero actually, because this value was a zero. This expert said there was no chance of establishment by 2021. If we take expert 4, you can see there's more spread on the upper values than on the lower values, but the overall spread is far less than expert 1 had. And when we look at this, we see expert 2, 3, and 4 all had this probability as relatively low, about 1% or less. Expert 5 was a bit more uncertain. Expert 6 a bit more uncertain still. So you can look at this graph, and this says we don't have agreement among the experts. When we calculate the composite expert, that looks like this. The composite expert is not really representative of the low opinions, and it's not really representative of this high opinion, but it's representative overall of the average of all of these opinions. When you look at the with condition probability of establishment by 2031, we see the same pattern. Expert 1 is at the extreme here. Expert 2 is a little different now. Expert 2 is beginning to become uncertain. Expert 3 and 4 still down near the zero end, and you can see experts 5 and 6 in their relative positions. Expert, or the composite expert, once again somewhat close to expert 6. If we look at 2071, expert 1's uncertainty is reducing. This person feels certain, or relatively speaking, more certain that there will be establishment by 2071. Expert 2, by contrast, is becoming more uncertain. So once again, you can take a look at how the experts came out on this. 1 feels that the establishment is virtually inevitable. 3 indicate that it's relatively unlikely. 2 indicate something in between. And so we have a composite expert here that we use. This is a graphic that you saw just a few minutes ago where we put the medians in and could compare the probability of establishment under without project conditions for 2021, 2031, and 2071. The little arrows are indicating that there's almost a tripling of the probabilities from 21 to 31, and then again from 31 to 71. It would be important for our decision makers to know how the experts vary. So here we have a summary that shows all the values for a given expert. So this is expert 1 who felt that the probability of establishment was virtually certain. The without condition way up here near 1. The electric barrier dropped that down from about the high 90s to the 20s. Closing the lock would look like it would be a relatively effective measure. What we do find when looking at this is you want to see what's the same about these experts, what's different. And one thing that's different is the amount of uncertainty that they have, the values that were obtained with their various levels of input. But we find that there is a constancy in the effectiveness. They say the non-structural would be the least effective, followed by complex noise, barrier and noise, electric barrier, and then the closing the lock would be most effective. Here we see the without condition, non-structural, complex noise, barrier and noise, electric barrier, and closing the lock. You'll notice again that there are differences. The scales are important. This goes from 0 to 1. This goes from 0 to 0.6. As we look down here at our other experts, expert 3, notice the scale here from 0 to 0.003. This person doesn't think that there's even a 1% chance of establishment. Here we have from 0 to 0.02. So this person is in pretty close agreement with that assessment. You'll also notice here that this person doesn't feel like there is much to distinguish the plans, that they're not going to be terribly effective, or they're not going to be noticeable differences in their effectiveness. We get a similar view over here. Here we have 0 to 4%. We have the same order of effectiveness of the plans that we saw before, and we have the same order of effectiveness of plans here. Only some of the experts, expert 6, experts 1 and 2, seem to have the view that there will be some effectiveness. But then you have to counter that with the small numbers that the other experts were using. So conveying this information to decision makers is going to be a challenge. When we're trying to convey the effectiveness of plans, let's see if we can add, we have the non-structural plan, the barrier, will add the noise plan here. There's the plan with noise, and if we add, let me see, we get the barrier and noise, and add that to our graphic. This graphic shows the effectiveness of the different plans. I've left out the non-structural, so let me add that. So now you can see the effectiveness of the different plans. Here is the without condition, the non-structural plan. Here's complex noise. Here's the noise in the barrier. Here's the barrier. Here is the lock closure. So we're going to be asking decision makers to make decisions with data like this now. And as I mentioned earlier, that's a brave new world, and it's going to be changing and challenging a lot of people.